Hi everybody, in this video we're looking at polyatomic ion compounds. Now if you don't know what a polyatomic ion is, I would stop this video right now and go watch my video on what is a polyatomic ion, because that's going to help. If you're in my class too, it's a good idea to have table 5 out on your reference tables, because that's got a listing of the most common polyatomic ions, and we're going to use them quite a bit in this video. If you don't have access to table 5, I've got it popped up in this video here too. So first, let's just start with our unit outline. We've talked about ionic substances. This is kind of our last piece in the ionic category. We are going to stay in the ionic category for this piece, and we're looking at this last part, polyatomic ion compounds. So here we go. This is that table I mentioned earlier, table 5, which has some of the most common polyatomic ions. This is not a full list of polyatomic ions. This is just the most common ones. But good ones to kind of memorize. In my class, we're looking at just, I think, 14 of these to memorize because they are the most common. But we'll end up using these quite a bit in this part of the unit. So we'll refer back to that in a second. Now, polyatomic ions can be negative or positive. Most often, they're negative. If you look at that table, you'll see that most of the polyatomic ions have a negative charge. And so the general formula for naming these things is going to be to name the metal element that a polyatomic anion has bonded to. And so you end up with metal name, space, polyatomic anion name. But like I mentioned, not all of them are negative. Some of them are positive. If you look, +1 charge, +2 charge. And so less common, but still possible, I could have a polyatomic cation bonded to a nonmetal. And so if that's the case, you're going to use kind of this second layer of a template here where you have polyatomic cation, which is positive ion. Put that name first, and then a space with the nonmetal ide name. It's more common to have 2 polyatomic ions bonded to each other. So the third kind of possibility here is that we have a polyatomic cation bonded with a polyatomic anion. And if that's the case, you just simply put the cation polyatomic ion name first, and then the polyatomic anion name second. What? Look at this screen for a second. There are 3 layers to this, and they represent 3 different scenarios. The first scenario is when your polyatomic ion is negative. The second is when it's positive. And the third is when you have a positive and a negative. So you're not going to follow all of these at once. You're just going to follow one of them depending on what you're naming or writing the formula for. So let's start with an example. Let's say I have KOH. Well, the more you do these and the more you look at these substances, the more you'll quickly pick out which is the polyatomic ion here. The polyatomic ion in this one is hydroxide. You can see it OH minus. So hydroxide is the anion in this, and that means I'm going to have potassium's name first and then hydroxide at the end. So the name ends up being potassium hydroxide. So another example here, MgClO4 2. Now anything that's in parentheses is going to be your polyatomic ion. So ClO4 is perchlorate. So this is magnesium perchlorate. Okay, not too bad. Not too bad as long as you have table 5. CuSCN. Well, SCN is the polyatomic ion here. That's thiocyanate. But be careful. This is copper. And now, if you remember from our last video, there are some multivalent metals. Copper is one of them. So that means we need to look at the charge of SCN. That's -1. And so if there's 1 SCN and 1 copper atom, then that means we are dealing with copper 1 thiocyanate, not copper 2 thiocyanate. So some of these rules can start to layer in with each other, and this is an example where that happens. One more example, NH4OH. Now look, this is one that actually has 2 polyatomic ions in it. NH4 plus 1 is ammonium, and then OH minus 1 is hydroxide. So we just simply call this ammonium hydroxide. Okay, let's do one from this side of the table here because we're just doing positive and -1. Here's where we have a positive or a -2. This is carbonate, CO3. See, it's first on that list there. It's bonded to sodium. Notice it needs 2 sodium ions to bond to it because sodium has a +1 charge. Carbonate has a -2 charge. So the name for this, sodium carbonate. You really don't have to look at the charges to figure out the name for it, but we're soon going to go in the opposite direction where we go from name to formula. It's a good idea to know how to do that. Last example, MnPO4. Well, again, Mn is a multivalent metal. I have to look at PO4. I've got one PO4. That's a phosphate ion. It's got a -3 charge, but I only have one manganese atom or ion, so that means this has to be manganese 3 phosphate. Okay, what if I went in the opposite direction? If I gave you the name, could you give me the formula? Potassium chromate. Now you have to look at the charges for these. Potassium has a +1 charge because K is in group 1. Chromate, you got to find chromate in our list. Here's chromate. Chromate has a -2 charge. And so I really just kind of covered it up there, but it's a -2 charge. I really just want to look at the charges. So it's just like crisscrossing like we've done before. So potassium is K. I have K. Chromate is CrO4. I need 2 potassiums, and so you just kind of slide these together. So you end up with K2CrO4. All right, here's another one. This one says lithium hydroxide. So lithium has a +1 charge. It's in group 1. Hydroxide's over here. It's got a -1 charge. So that means I just need one of each. LiOH becomes my formula. Here's another one. This one says iron 2 nitrate. Ooh, we've got a multivalent metal here. So I've got Fe2+ here. And then nitrate. Nitrate is over here. It's got a -1 charge. So NO3 with a -1. So I'm going to crisscross here, but here I need 2 nitrate ions. And so I'm going to end up having to put parentheses around the nitrate, NO3. And so my formula becomes FeNO32. Okay, here's another one. We've got ammonium acetate. So this is one that's got 2 different polyatomic ions in it. Ammonium is up here. It's got a +1 charge. So NH4 with a +1 charge. Kind of hard to see the 4. Sometimes people think that that's NH with a 4+ charge. Don't be that person. And then acetate, that's this one here. And so I've got kind of a long one, C2H3O2. That whole thing has a -1 charge. So we've got +1 and -1. That means I just need one of each, which I realize is difficult to see one of each here, given that there's 4, 2, 3, 2. But you'll eventually start to realize, okay, well, that's ammonium and that's acetate. So more practice will help you there. So that's it. We've checked off polyatomic ion compounds. It's not too bad as long as you have a listing of tables, but the more you use this, the easier it becomes to name polyatomic ion substances. Thank you.